Electrolysis is very easy, but most students find it difficult. But I don't know why. Let me teach you. Now, as you can see, this is a typical electrolytic cell, right? Now, this is a branch. The actual thing is electrochemistry. Now, electrochemistry is a branch of chemistry, right? So we can have electrolysis and electrochemical reaction. So when we talk about half cell equation, those are the electrochemical reactions. The electrochemical cell. Now, here we are talking about electrolysis, which is a branch, which is a part of electrochemistry. Now, look at the word electro, that's electricity, and lysis means to break. That means when electricity, right, electricity is allowed to break a chemical compound into its ions. That's electrolysis. Electricity allowed to break down chemical reaction, right? That's electrolysis. But electrochemical cell is the reverse. Chemical reaction combines, then I produce light, then I produce electricity. So when you convert electrical energy to chemical energy, we say that's electrolysis. But when you convert chemical energy to electrical energy, we say that's what? Electrochemical cell. Because you light up a bulb. That's why your Tiger battery is a cell. It's one of the primary, it's an example of primary cell that is used to produce light. Can you see? Very easy, but students don't know it, they don't understand. But follow me. You're in the right place. Let's get it to work. So now you must understand that this is the positive pole of the electricity you want to pass. Now, this positive pole will allow current to enter. So current enters through the what? Through the anode, and electrons leaves through the anode. So current enters through the anode and electron leaves through the anode. So that means if you know that current enters through the anode, you will understand that current will leave through the cathode and electron will enter through the cathode. Just like it's the opposite now. If current is entering through the anode, definitely current should be leaving through the cathode, because these are the electrodes, they are terminals that allow for the passage of current and electrons. Now, but there's a mnemonic you should know, and that is cell. But the cell is EE. So for anode, so A cell. For anode, current enters, and electron leaves. So once you know this, you know that for anode, this is anode. So this will be the opposite for cathode. Current leaves, then electron enters for cathode. So no cramming, no pressure. Okay. So let's get into work. Well, if you have not read anything at all, or you are stuck with your reading, so you can see here we've broke down all your subjects, all your syllabus into 7 days. I'll be inviting about 15 of my medical colleagues to teach you, and myself will be taking you to a closed WhatsApp group and teaching you live and direct. Okay, so this is going to be one of the best things you want to do for yourself. If you have not read anything, send me a DM, send the word marathon. If you're listening to this on YouTube, you'll see my number around there. Send to me on WhatsApp, or if you're listening to me on TikTok, send me a message on TikTok with the word marathon to register for this. Registration ends on April 15. Okay, the class starts in April 17 to April 23. Okay, so you want to register, and you want to say bye-bye to all the difficult stuff. So let's get into work. Now, this is just the basic thing, electrolytic cell. No pressure. But the major thing I'm going to be focusing on in this particular video is the product that will be formed at the anode or cathode of an electrolytic reaction. Now, I've done the one that deals with the calculation aspect, the Faraday first law, the Faraday second law. But if time permits, I might have to talk about it here. But let's get to work. So I'll be discussing it in different cases. So the first thing I'll be talking about is electrolysis of acidified water. It happens in Hoffman voltameter. Electrolysis of what? Acidified water, which occurs in what? Hoffman voltameter. Electrolysis of acidified water. Now, what do I mean? I'm just trying to say electrolysis of dilute H2SO4. One common JAMB question is that where does it occur? It occurs in a device we call Hoffman voltameter. It's another JAMB question. Hoffman voltameter, not voltmeter, voltameter. So let's get to work. Now, I will teach you like a JAMB student. I will not teach you like a YX student, because if it's a YX student, there are things I must tell you. but this is a JAMB student. Okay, it's also important, but I don't want to waste time because there's no time. Now you have to take note of something, that for dilute H2SO4, the ions present, right, is what? H2SO4 is here. Don't forget that even if it is dilute or conc, there is still water. So that means water is here. So for this guy, the ions present here will be what? H plus and SO4 2 minus. Right? For this, it will be what? H plus what? OH minus. Just like I see. H2, then SO4 2 minus. But it's not balanced. You can balance because this is 2. You want to add 2 here. That means these are the ions present. Abi? So these are the ions present. H plus and SO4 2 minus. Then H plus and what? OH minus. Now, that means these are the ion present because it is dilute. If it is conc too, there will be water. The difference is that for conc, the water is just smaller than the solute. For dilute, the water is more than the solute, like this acid that is dissolved in it. Okay. Now that means these are the positive guys, these are the negative guys. Now their job is to go to either anode or cathode. Now look at it. These are the girls. I am the guy, and the guy is the anode because anode is what? Anode is positive. These are the guys. They want to meet the girl. The girl is negative because cathode is negative. Don't forget, this is electrolytic cell. When it gets to electrochemical cell, this change and becomes positive. Then this one becomes negative for electrochemical. But electrolytic, this anode is positive. This cathode is negative. Even if they change, what still happens there is the same thing. What still happens is what? Is the same thing. Look at what happened. What happened at cathode is still follows cryo. Cathode reduction. Cathode what? Reduction. Anode oxidation. So at cathode, we still have reduction. At anode, we still have reduction. Oxidation, sorry. Now, regardless of this, you must know what is reduction, what is oxidation. And that's why you must know the second thing, which we call what? Lyoga. Lyoga. So from there, we'll now continue. Lyoga. Lyoga. What does Lyoga mean? Loss of electron. That is what? Oxidation. Gain of electron. That's what? Reduction. So you must know this because you will need it in all this thing that we'll be doing. Now, we've gotten what we migrate to the cathode. We've gotten what we migrate to the where? To the anode. Just based on the girls will come and meet the guy. The guys, positive guys, will come and meet the girl, which is negative. Now, how will the discharge happens? Okay. So for the discharge to happen, you must know the table. What is the table? And that is, you start from below. Oh, I borrow chlorine. Chlorine, not sulfur F. Well, this is the chemistry tutor. Is on YouTube. You can go and subscribe to it. I upload videos there every day. That means, of course, you know that fluorine is the most electronegative element, abi? So that means this is F minus. That means it's stronger than this. But this sulfur is not sulfur. It is for SO4 2 minus. This is NO3 minus. This is Cl minus. This is Br minus. This is I minus. And this is what? OH minus. So this is bromide ion. This is iodide ion. This is chloride ion. This is OH. Now that means the strength, this is what we call electronegativity series. That means the strength will decrease as you go down. The strength will what? Will decrease as you go down. Because of course, fluorine should be greater than this guy. Now let's come here. Just like I said, which one will be discharged? Which one will be discharged? Which one will be discharged? Now look at it. I'm the guy. This is me. I'm the guy, Abi. And I want to date one of these girls. Okay, and I check their series. This is where I can determine which girl to date. After checking their series, I realized that SO4 2 minus is she has SO4 2 minus has more money. Like you can see, is stronger than OH. Now, discharge of ions is trying to tell us which one to send away, which one to eliminate, right? Now, SO4, I would prefer to date SO4 2 minus because it's stronger than OH. So I will decide to send OH minus away. So I will keep SO4 minus to myself. Okay, that is what happened. So at the anode, this is the JAMB question, because JAMB will ask you what will be discharged at the anode. So it's OH minus that will be discharged, but what will be liberated is what we tell you now. Now, you must never forget this equation. When we have OH minus being discharged, it will give water, oxygen, and of course, electron. Okay, of course, electron. Now, let me add the electron here. Electron, because I must balance it. Now, this is not balanced. How do I balance it? Don't disturb yourself, because you must know this reaction. It will appear in almost all the questions you'll be doing. So that means this will be 4. I will tell you, then this will be 2. Then this will be 4. How? No pressure. How many oxygen is this? 4. Now, 2 of oxygen, that's 2 plus 2. That means the oxygen is balanced. 4 of hydrogen, right? 2 times 2, hydrogen is balanced. Why is this 4? That is the question. Now, look at it. This is 4. You can see the electron here, right? You can see the minus here. Now, that means the electron that is here must be losing. Don't forget, this is anode. What did I tell you happens at the anode? Cryo. Cryo. At the anode, oxidation. And oxidation is what? Loss of electron. Loss of electron. That's why this electron is being lost. Because how will it be lost? It will be going to the other side, right? Or some textbook will say when you bring this one here, it will be negative. But don't worry. Don't let me disturb you with that. So it will be going to the other side. So the question is, what is being liberated at the anode for electrolysis of acidified water? Oxygen gas. And it is 1 mole. It is what? 1 mole. And another question that you must know is that how many moles of electron is required to discharge 1 mole of oxygen? It's a JAMB question. Can you see? 4 moles. Because this is 1 mole of oxygen, right? 4 moles is required to discharge 1 mole of oxygen. So that's another JAMB question. Can you see? So this is what will happen at the anode. Now, what will happen at the cathode is very easy. Please don't ever forget this equation. Like, regardless of what you do. Now, don't forget, we already said what will be at the cathode. We already said they are H plus and H plus. Those are the guys that will go and meet cathode, because cathode is what? Negative. So 2 guys will go and meet the girl. But the girl just saw that, oh, when he considered the electropositivity series, okay, I made a video on electropositivity series already. When I already explained, popular scientists can make a zoo. Okay, that's zinc. This is aluminum, this is zinc. In the low, you understand? This is iron. I've already made a video on this, but hydrogen is somewhere around here. So, but then the 2 guys that is coming to meet the girl, they are both hydrogen. The girl will just be like, there's no pressure. Don't let me decide. Let me just pick one of them. So we just discharge this guy. So now 4H plus 4E to give 2 hydrogen gas. Now, you might be wondering, why am I using this for now? Maybe I should start with 1. Don't forget that if this is cathode, don't forget that if anode is losing 4 electrons, who is gaining it? Cathode must be gaining it. So that's why this must be 4. And that's why I must write 4 here. And don't forget that electrons are negative. So that is why they are balancing this guy to cancel it out. 4 of this, that's why we have 4 here. Okay, so that this guy can cancel this guy out. So hydrogen is 4, and 2 times 2 is what? 4. So that is what will be liberated at the cathode, because cathode is what? Negative. Now, what is another JAMB question? What is the mole of hydrogen gas being liberated? 2. What is the mole of oxygen? 1. So it is 2:1. That's a JAMB question. It is what? 2:1. It's a JAMB question that you must know. And this thing happens in what? Hoffman voltameter. Now look at it. H plus is leaving. OH plus is leaving. So the next question is, what is the end product? End product. End what? End product. Don't forget that H plus and SO4 2 minus, and H plus and what? OH minus. That means I've taken this guy, right? And I've taken this guy. So what is left? I'm left. So this H plus and OH minus, they are leaving in form of water eventually. That means the dilute H2SO4 will become conc, because look at what is left. I left one of these H plus what? SO4 2 minus. So eventually this becomes what? H2SO4. But it will not become dilute. It will be what? Concentrated, because I've already removed these two guys in form of H plus and OH minus. They have gone. So this will become concentrated H2SO4. So this is the end product. The product at the cathode is oxygen gas. The product at the anode is, the product at the cathode is hydrogen gas. The product at the cathode is hydrogen, anode is what? Oxygen. So the question I've asked you, I've already said it before. What is the device used for this particular electrolysis? Is what? Just drop in the comment section. I want to see those that that really understand what I've been saying. So this is the first one that you must know. So we'll now go to the second one, which is electrolysis of dilute NaCl. Electrolysis of dilute NaCl. So you must never forget this thing. Oh, I borrow chlorine, not sulfur F. You must never forget this thing. Okay, so let's go into that. Now let's say electrolysis of dilute NaCl. And you must never forget this one for positive, for metals. This for non-metals. We'll be fast here. Number 2, electrolysis of dilute NaCl. Okay. Now, what happened? Same thing. Dilute. There's still water there. So, what are the ions? NaCl. We go to what? Na and Cl minus. Then H2O will be there. Then this become H plus and what? OH minus. So these are the negative guys. These are the positive. Now the positive, we go and meet what? We go and meet the cathode, which is negative. This guy, we go and meet the anode, which is what? Positive. Now the next step is, which one will be discharged? Just come here. Look at this guy. This is Cl. This is OH. Which one will you prefer to marry? Cl is stronger than OH. So I will keep Cl and I will send OH away. That is the deal. Because it's dilute. So in this case, what is actually determining this is what we call position of ions in the electrochemical series. It's one of the factors necessary for the discharge of ions. There are 3. Number 1, position of ions in the electrochemical series. Number 2, the concentration of ions. Number 3, nature of electrodes. Okay. Now, definitely, OH will be discharged. So at anode, no pressure. Can you see that? Why I told you to know that equation? You see that we are using it again. 4OH minus to give 2H2O plus O2 plus what? 4E. That's what will happen. So oxygen is being liberated at the anode during electrolysis of dilute NaCl. Now this one, what will be liberated at the cathode? What will be liberated? Look at what will happen. Look at what will happen. Look at what will happen. You know, I told you something the other time. I need this table. You must never forget. I need this table. So I told you that popular scientist can make a zoo. Abi, don't forget. Let me just go up to hydrogen, because these are the 2 things I need: sodium and hydrogen. Now look at the girl. The girl wants to pick a guy out of the 2. Now which one will you prefer to pick? The girl will prefer to pick to date sodium, because hydrogen is lower. So the girl will eliminate hydrogen and date sodium. That is the idea. So this will be discharged, because this one is going to hold on to the girl. The girl is going to hold on to this one because it's higher in the series. So that's why this will become 4H plus 4E to give what? To give 2 hydrogen gas. So this is the product at the what? At the cathode. What do you observe when we talk about hydrogen gas being liberated? Is at the cathode, because hydrogen gas here is positive, and that's when they will go. So eventually the end product, what are the things that is left after the discharge? There are 2 things that is left. What are the things? Na is left and Cl is left. These are the things we just eliminated. So eventually NaCl. But don't forget, there will be what? There will be concentrated because I've eliminated water. So this will become concentrated NaCl. Okay, concentrated NaCl. Now, concentrated NaCl because why? I've already removed water. Okay, this is electrolysis of dilute NaCl. Now, if it is molten, let's talk about that. Molten NaCl. What they call molten. Look at it. Can you see? This is what they call molten. Can you see? There's no water. There's no water. You wasted my toothpaste. Okay, but that's by the way. Now, electrolysis of molten NaCl. Can you see? That means there's no water. So the ions present will just be what? Na plus and Cl minus. Can you see that toothpaste? There's no water. That's what they call molten. Okay. So now that means discharge. What will happen? Na, the anode is positive. That means the negative gas will come here. Then because Cl minus, right? Now I already told you that what happened at the anode? Cryo. Anode is oxidation. And oxidation is what? Loss of electron. So eventually this one will be what? This will be this. Then to give chlorine gas plus 2E. Why is it 2E? Because it is 2 of this, right? Now, cathode, what will come here? This guy will come here because it is what? Positive. It will come and meet the girl. The guy will come and meet the girl. The girl will come and meet the guy. So why am I going to add 2 here? Because it is losing 2 electrons. You must be gaining 2 electrons too. Then to give what? Na. How many? 2 Na. So these are the product at the anode. This is the product at the cathode. Doing electrolysis of what? Molten NaCl. Shike now. There's no end product. There's nothing. Just sodium being deposited at the cathode. Just chlorine gas being liberated at the what? At the anode. So that's just it. I hope you enjoyed that. Okay, so we'll be going to electrolysis of what's the next thing? Electrolysis of brine solution, right? Conc NaCl. That's brine solution.